Yes, I think we can start. So today topic is about, I think you already know it, Kubernetes. So you might have heard it recently, lots of times you know, we are learning DevOps or who are working on it currently. So the main tool you might be saying I'm working on this tool, something called Kubernetes. Kubernetes, not nets, just Netes. So we'll talk about that today. We'll start with introduction, if possible, installation also, hopefully. But yeah, let's start with Kubernetes and what it is and how it helps us. First, let's start with Docker Swarm. Let's go back to Docker Swarm. In the last class, we have discussed, right? Yeah, I know what is Docker Swarm and all. So let's go there. So Docker Swarm, it's again it's a cluster, where we can deploy multiple containers. But if you remember, I told few drawbacks in Docker Swarm that one is auto scaling. Based on the incoming traffic, the container should scale up and scale down. I mean, increase the count and decrease the count. Scale up or scale down. But it's not available. I mean, this feature is not available in Docker Swarm. That is one thing. Another thing is rollbacks and rolling updates. So what does it mean? Rolling updates is I'll be deploying a new version. My application, let's say I made some changes and I want to deploy the new version. So we'll do rolling updates, one by one, two by two, three by three, something like this. I mean, like a batch wise. This is called rolling updates. I mean, replace the new with the old, like this. Not at a time. Because if we do at a time, we'll see a downtime, right? That's one. And there is one more thing called rollbacks, going back to older versions. Let's say deployed today, but it's not working as expected. I have to go back to my previous code, right? Obviously. So that those are called rollbacks. So that is also not possible in Docker Hub. Sorry, Docker Swarm. And we have seen one more case. Let's say I told Docker Swarm that, hey, I want 5 containers. Maybe accidentally something got deleted. Will Docker Swarm make it up? I mean, let's say out of 5, 2 are deleted. So what will Docker Swarm do then? Will it create 2 new containers or it won't?
It won't.
Yeah, exactly. It won't. But I want 5 because my requirement is 5. But Docker Swarm, it cannot do it. Of course, it's not bad. I mean, Docker Swarm is bad thing or something like that. But these are the very common things for an application, you know, which we require on, for every application, not just one. These are very minimal requirements. At the time, Kubernetes came into picture. In 2013, Docker came, I mean, Docker was there earlier also, but it was famous, got famous in 13. It launched in 13 and got famous in I think 15 or 16. Kubernetes came in maybe 17 or something, somewhere. If someone says I have 10 years of experience in Kubernetes, they're lying, they don't. Because maybe Google guys might work on it, but general, everyone, common DevOps guys, we don't see Kubernetes from that far. Not for 10 years, obviously. Maybe 8 or 7, or mostly. But yeah, that's fine. Forget about that. So Kubernetes is a tool. Simply, it's an tool which is available in the market. Why? Why it is available is to deploy your applications. To keep it simple, to deploy your containers, to manage your containers. Of course, we have Docker Swarm, but I told you there are a few limitations. That's why Kubernetes came into picture, to cover those limitations from Docker Swarm by Docker Swarm. So it has the advantages whatever we felt that they are missing in the Docker Swarm. All those features are available in Kubernetes. Simply, Kubernetes is maybe I would say like just to understand purpose. I mean, Docker Swarm Kubernetes works for the same thing. They are both are clusters. They're both are clusters to maintain the containers. All difference comes is the capacity. the features it will give you. Let's say you have two cars. Obviously, you'll compare these two, right? Maybe it depends on the mileage, depends on the look and feel, maybe, or depends on the cost also. So out of that, you'll choose the best one. So similarly here also, these two are same thing, does same thing, but few differences. Maybe in terms of capacity, in terms of features availability. So most people nowadays go for Kubernetes because of these features advantages what it has. As I told you, the rollbacks, rolling updates, auto scaling. We call another thing called self healing because I told you right. I want five, but something got some issue or the container it got deleted. Kubernetes will recreate that. It will make sure whatever the number we gave to that, it will try to maintain that. Let's say if I told Kubernetes like, hey, I want five containers to be running all the time. Kubernetes try to do that. If something goes wrong, some one container got deleted out of five, immediately it'll recreate another one. Because we told that I want five, that's it. We don't care about how it will create, but it will do it. Unless the cluster is down, I mean, obviously. But yeah. So I'm not saying a definition, I'm just saying what it will do in terms of general talk, how we generally talk on regular basis. You might see here, like simple definition. Kubernetes is also known as K8s. You may, I mean, we call it K8s or Kubernetes, both are same. But what does it K8s mean? You can see here, right, the Kubernetes word K and S starting and K and ending S. In between there are 8 letters. UBE 3, 4, 5, 6, 7, 8. That's why K8s. That's it. Not nothing. You can call anything, no problem. So it's an actually open source, software for automating our deployments, for scaling, for managing our containers. That's what we did, right, with Docker, managing our containers, running them, creating them with Docker Run, Docker Compose, Docker Swarm. Without using any of those, we do all those tasks using Kubernetes. Why and all, we'll, as I told you, a few things, but we'll see them in practical. One by one, don't worry about that. So again, remember, it's for containers, not for some normal VMs. So what is the advantage is, apart from these, the capacity mainly actually, because Kubernetes, once you deploy an application, you know, once you deploy, your application inside the cluster, I mean, similar like Docker Swarm, let's say you create a service, it can handle request. That's fine, but Kubernetes have more capacity in terms of running the applications, I would say. I mean, of course, it depends on the resources, obviously, ultimately, but it can handle that much applications. Let's say we have a server with 100 GB memory, as an example, 100 GB RAM. Docker Swarm is running, and you ran some 1,000 containers. Docker Swarm will crash because inbuilt it does not have that capacity to handle these many number of containers. Of course, Docker Swarm is useful very much, but small scale applications, small in a number of containers. But let's say, as I told you, 1,000 containers. No, Docker Swarm can't handle it, but Kubernetes can do that with the same resources. That's the main difference. Of course, as I mentioned, other remaining things you may have. So there are so many companies, not just one company. There is lots of. I think nowadays everyone uses Kubernetes. Whoever have DevOps implemented in their organization in IT, everyone uses Kubernetes. So there is no organization without using this, obviously. It all started with Google. Yeah, builds upon 15 years experience of running production in Google. Of course, it's not open source at that time. As I told you, right? It got famous like 2018 or something, 17, maybe, if I remember correctly. But it was there it was available, but it's not an open source project. When we use the tool, when it became open source. For each and every tool, company can't pay, right? So it was developed by Google. There is something, I think, Korg. The project name is Korg. Korg or Borg, if I remember correctly. I think Borg, Borg. So there is a project called Borg at Google. So Kubernetes was designed by those engineers who were working for this project. And in 2015, the Kubernetes application has donated to CNCF. It's like Cloud Native Computing Foundation. So they made it open source. See, 2015, 9 years mostly. And of course, immediately we don't, no one uses it, right? It will take some time. And Red Hat is the first one, first companies to work with Google on Kubernetes. Even before the launch, so Red Hat has become the now leading contributor to the Kubernetes project at the time. And later once became famous, once became open source, it became famous, everyone started using it. Of course, it's open source, free. So everyone started using it, and of course it has its advantages. You may ask, earlier to that, what we used to do? Earlier to that, Docker was released, I think 2013, if I remember. Let's see. Docker 2013, March 20, just 2 years. So within 2 years, people are just running Docker containers with Swarm, with Docker Compose or Docker Run. So after Kubernetes came, they started slowly improving everything. Because even the containers concept, Docker concept is very new by the time of 2015. So this Kubernetes came into the picture, and changed everything. The way we deploy things changed everything because it's that much easy to deploy our application Kubernetes. I mean, Docker Swarm also the same thing, right? The containers concept changed everything, and these two are the main thing pillars I would say in containers concepts, Docker and Kubernetes. So, of course, there are other tools also, but these two are the main things. So just an orchestration tool, or you can say it's container orchestration tool. Orchestration, my it's like I know orchestration. To keep it simple, what is that orchestration means is it allows us to build applications and where multiple copies or application can be run together. So that's called orchestration. And of course, managing those applications and everything comes under orchestration, which we do automatically, not manual. So this is an orchestration tool which manages the applications, deploy our services and everything. And for container applications, that's why we call it container orchestration tool. So it is a container orchestration tool which is open source to deploy our applications, manage our applications, scale them, monitor, load balance, and everything. It's not a replacement of Docker, no. It is just another tool to manage your containers. That's it. Because ultimately, here, Kubernetes what will do is it will just deploy your applications and manage them. Like, whatever I told, right? It will manage them. It will, if something goes wrong, it will create again. It will make sure they're running. But how we run the container? Once we build the image, the building imaging part is not available in Kubernetes. Kubernetes just manage your containers, not build your images. It does not do that. No, it just manage your containers. That's it. So image building has to be through Docker. And there are other services also called Containerd, which is a little famous after Docker. So where we can use the same thing. Whatever we do with Docker, we do the same thing with Containerd, building images and everything. So Kubernetes supports that also. In recent version of Kubernetes, uh, sorry, let's not go there because we haven't started that concept yet, but let's keep it. But yeah, the image building is not possible with Kubernetes. Just after building image, we have to deploy it. So that part it will handle, not the running part, so not the building part. That's what it does. So, so like these Kubernetes brings us advantages, and of course, it's a cluster. Means similar to Docker Swarm, what we see cluster means nothing but a group of servers, a group of anything usually. So here, since we are talking in IT terms, so cluster is a group of servers. Of course, just like Swarm, there will be a master, there will be nodes. Every nodes will be report to master. I told you that earlier. So these were similar, but the difference is in the features availability, obviously. So that's why the working is same. The working, module is same, model is same. There will be a master, there will be nodes. Master will control them. Master will deploy the applications in the nodes and everything. The where the difference comes then the capacity, the features, and of course the installation obviously. So it's a cluster, so which is group of hosts, and of course it's only available for Linux machines, not in Windows. It means only for Linux containers, only for Linux environments. So let's say this is my Windows machine, right? I cannot install Kubernetes in Windows machine. No, it's not possible. I have to run Kubernetes in Linux only. It, everyone use Linux obviously. So you may ask how to do then. I mean, I don't have a Linux laptop. I mean, I have Windows. That's why there is something called the platform side. When we install Docker, if you install Docker desktop in Windows, there will be a WSL platform which will allows you to run Linux things on Windows. So you use that, but that's okay. That's fine. So now coming to, come on, where is this?
Bro, whenever you say auto alignment, which is nothing but auto scaling, right?
Auto
So
alignment.
in generally in Docker, yeah, like when one container goes down, it can be
Yes,
auto
that's called
upgrade the new one, right?
scaling high availability. That's called to
Scaling.
maintain it. Auto scaling will come a little different. Auto scaling will comes. How would I describe it? It will make sure the scaling, scale up the container, scale down the containers automatically. When depends on the load, the traffic, whatever we are receiving. High availability is related to auto scaling. It will make sure that the application is running always. It means the point which you just said. If one goes down, it will automatically make sure it's up. That's called high availability.
Okay. So generally we execute commands in the Docker form for auto scaling and all, but here it can be
It
automatic,
can be,
right?
yes, exactly.
In Kubernetes.
Well, last time I think we did last time. Docker service name,
Yes.
scale, something
Scale.
command, right? So
Yeah.
that's
Scale
manual.
service name equal to flag.
Exactly, sorry, yeah, that's manual. But here it's automatic.
Okay.
Depends on the requirement, it'll do it. So we don't need to bother about it.
Okay.
Go ahead. So I'm
Yeah.
just
Yes.
okay, sorry. I'm just trying to show you the architecture. Let me just why it is. So yeah, that's okay. How Kubernetes looks like, the architecture I'm trying to show you. Just like Docker Swarm, there is no difference in the architecture, of course. So this is, let me write it first. This is master. These are nodes. In Kubernetes, we call them workers. That's it. Worker 2, worker 3, worker 4. So master will control all these things, what to deploy, where to deploy. Similarly, in Docker Swarm, we have manager. I mean, manager, master, leader, all are same here. So that will control because where to run, how many to run, because we give the commands in master only, correct? In Docker Swarm also, we give the commands, whatever the commands, in manager. I mean, in master, not in slave. I mean, not in worker or node, because it doesn't know. It does. These nodes does not do anything. Everything will be done by master. So whatever the inputs will go from here to master. Obviously, that's what it does. Correct. So now we see, of course, we know Kubernetes. Okay, this will do. It's a tool, orchestration tool, container. It will manage the containers and everything. So and it has architecture like master and multiple the n number of nodes, whatever the nodes depends on the requirement. How this thing works internally, that we'll see now. So first Let's give a name. Master, there is one more name for master called control plane. Let me just expand it. Sorry. Oh, sorry. How to increase the size? Okay, I'm not sure, but that's okay. Sorry. Control plane. 1 minute. Control plane. Here it is. 18. Yes. Master or control plane, we call it. What do we call these? We can call these compute missions. Compute missions or data plane. Sorry, did I wrong? Or data plane. We call any of this. Control plane is obviously this is where we do the everything, every task. So this is control plane is responsible for managing the cluster, such as deploying our applications, how many they want to run, everything. Just like in Docker, we do everything, service creation, everything from master, nothing but a control plane. So we just simply go to master node, I mean this control plane node, and run something, some command, whichever Kubernetes command. We'll see that next classes. So and it will do it for you. That's it. So like let's say I told control plane, I went into master that and I said, hey, I want 10 containers of Nginx or some Tomcat something. Okay, it's created. That's it. So all we have to know is how it's created. That's the one. That's the thing, right? So you start a bike. It when you just click the self start or kick something, the bike started. But you're curious to know how, right? So 1 minute, sorry. Yeah. So you like to know how it's working. If you don't know how it's working internally, it will be difficult for you to troubleshoot. Let's say you have a bike and you know nothing about the bike. All you know is put the key, start the engine, and just start the kick or something or self start. It's fine, it's working fine. But in the middle of road, it stopped. You don't know what is the issue. We have fuel, everything is there. I mean, petrol, whatever it is it's full. It's tank full. So it's not the issue with fuel. Where the issue now? If you know about how it works, I mean, let's say there will be engine, there will be something or a clutch or something, whatever it is. If you know them and what is their purpose, it will be easy for you, right? To start a bike, I mean, maybe fix something or plug out the wire, plug in again, something, whatever you do, correct? Or anything, not just a bike, even with the phone, if you want to do something, change some setting, if you know the phone, whatever the ecosystem of the phone, you can do it, right? Similarly here also in Kubernetes, it will do what you want exactly. You said, hey, I want to deploy this, it will deploy it. It will do it for you. I want this one, it will do it for you. If something goes wrong, it automatically do it for you. But you have to know how this works. Then you'll know, okay, this is how it's working. Because with that information, it will be easy for you. If something goes wrong, let's say you told, hey, create 10 containers, but you didn't create it for some reason. Since you know the concept how it works, you know where to look, you know how to fix that, why you can figure out why it is not creating or doing whatever it is supposed to do. So similarly here also, so you have to know the internal structure how it works, then it will be easy for you. So coming to master, we'll start with master, I mean control plane, whatever it is. So we have major components. The first thing is API server. So the component called API server. This is the main component in the cluster. Whatever is happening in the cluster, whatever it's happening, whatever, no matter what it is, delete something, create something, update something, whatever it is, this is the responsible one. Let's say you told Kubernetes, hey, Kubernetes, I want to create something. This is the one which takes your input, which responds to your question and gives back the data. I mean, the output. So this is responsible for all the things happening in the cluster. Every action, this is the one responsible. Got it? Next thing we have etcd. Sorry. It is a key value data store. Just data store. It means just stores the data in a key value format. What does it mean? Key value is this is the key. Yeah, value. Like this format it will store. Let's say A colon 10. This is the key value. B colon 20. It will store the information in this format, key value format. What information about the cluster? I told because it's an cluster means multiple missions. How the master knows about which node is there, whether it is up or down, what's running in that, how it will know? It doesn't know anything, right? I mean, unless these guys inform to this API server because it's the main component, obviously. So for that, for this requirement, there is a service called etcd. This will gather information about the cluster, all the nodes, whatever is there present in the cluster. So gather the information and keep it with that. And whatever the information it's getting here, I mean, it's fetching from the nodes, it'll inform the API server. Let's say it fetches information about the status of everything. It will say to API server, hey API server, this is the information I got. Please take it. If something is wrong with the information, API server will take care of it. Got it? So API server 1, which is responsible for all the things happening in the cluster, and etcd is the one which stores the information, which gets the information of the cluster and informs the API server. Then only API server will know. Next, we have something called controller manager. I told you, right? What I told, I wanted to create 5 containers, but out of that, one container is down for some reason. What I told, Kubernetes will automatically create that one container which is missing. Correct? How it will do is, this guy is their controller manager. This guy will do the part, whatever the part, creation part. Controller manager is the one which will do the task. Like let's say I created 5 pods. What content this controller manager will do is it'll watch it. It will monitor that. Okay, this guy created 5 pods, and this duty of this controller manager is to watch the cluster, watch the state of the cluster. It will check. Okay, it will keep on tracking that. Okay, he told 5, but now it's currently 4 are there. Okay, it's my time to create that one missing pod. It will recreate it. It will create a new one in the place of the deleted one. So controller manager is the one which will do it. Now you may ask, oh, you told API server is the main thing. Okay, but why controller manager again? These are all interlinked. Let's say now the first one is etcd. Let's say etcd has the information of what's running, how many are running, right? etcd reports to API server. API server that hey, out of 5, 4 are running. It just reports. It does not do anything. And the API server takes the input. Okay, 4 are running. It's time to inform that to controller manager. So this controller manager will be triggered by API server. I don't say triggered. No, it's like sorry, what is that? Informed by, to keep it simple. Informed by API server that hey, it looks like one pod is missing. Please go do your duty. I mean, create the container. So then control manager will go and create it. Got it? The relation in how it works. And of course, there is one more component called scheduler. Scheduler is the one which decides where the pod, I mean, sorry, where the container should be deployed. I mean, you said controller manager is the one which deploys the containers, correct? Okay, that's correct. The scheduler is out of these four nodes where it should deploy. Controller manager thought I need to create one container, but out of these four, where? How does it know? It does not know. That will be taken care by scheduler. This scheduler is a component which decide where the container should be created. Where the container should be created. Out of these four, or let's include master also, out of these five, where should be deleted. This will decide. How it will decide? Based on our resources, CPU, RAM, based on the conditions that we gave to the application. Sometimes I want to run uh, my container in this worker 4 only, not other things. You can do that. Based on the condition, scheduler will deploy the application, sorry, container or application here. Let's say I told scheduler to run only here in worker 1. It will do it. So based on the conditions, based on the resources means the CPU, memory resources in the system or hard disk. So if let's say worker 3 is there, I told that I want to deploy the container in worker 3 only. So it will check it. Okay, memory is enough, so that we will deploy here. If let's say I told to deploy in worker 3, but there are not enough resources to deploy, it won't deploy it because the conditions are non matching. Of course, you told worker 3, but there will be conditions for resources also. So it's not matching. That's why it won't deploy there. So now here is the whole picture of how these things work. The first thing is, let's say in worker 3 pod is down for some reason. Sorry, container is down. So let's not go to pod. Container is down. Since API server, sorry, etcd have all the information of the cluster, it knows that okay, pod is the container is down, and this etcd will inform to API server. API server is like a boss, a manager, let's say. This guy API server takes the input from etcd. Okay, out of 5, 1 is missing, so only 4 are running. Now API server will tell to controller manager, hey, do your thing. The state is not matching with what the user is expected, so make it to the expected state. It means create the missing containers. Now container controller manager decide, okay, deploy this. How it will deploy? It will tell to scheduler, hey, I got a new requirement. I need to create one more container. I'm giving you the input. Take this and deploy it wherever it is available, based on the conditions. Now scheduler takes it finally, and it will deploy wherever it's available, based on the resources, based on no conditions. What is these conditions and resources? We'll see when we start working on it. Don't worry. But for now, imagine this as the resource based on the conditions that we gave. It can be memory resources, CPU resources. Okay. These are all called master components. I mean, control plane components, both are same. So they are working together. Got it? So any doubts in these components? Because very most common question asking in Kubernetes is define the architecture of Kubernetes. So you have to start like, okay, Kubernetes usually have master worker architecture. So in master we have a few components which are responsible for this cluster happening, starting with API server, etcd, controller manager, scheduler, these things. So that's how you start. It's not over yet, still there. Coming to nodes, okay, master components are okay now. Master, control plane, these are all the components which are happening, which will everything, blah blah, whatever it is. Nodes also in workers, I mean, nodes, workers, slaves, all are same. Nodes also there will be components, because you may think in this Docker Swarm, if you remember, once we initialize the Swarm cluster and master, it gave you token, right? With the token, you added, you joined the cluster. the node, whatever the node. The command, the join command, whatever join command will work only if the Docker is running, right? Correct? Obviously. If you don't have Docker, sorry, someone came. Sorry. Yeah. Let's say, can you execute Docker commands without installing Docker? No, right? Or can you execute Docker commands, create anything without running the Docker service? No. Or can you connect, let's say, Docker Swarm is there, I have 10 nodes. Out of that one node, I stopped the Docker service. Systemcity will stop Docker. It will show you not ready status because the service is not running. With the service only it's connecting. Similarly here also, each and every node there will be a service. So which will be running always, which will connect to this master from node. Each and every node it will be running. So that is called kubelet. So kubelet we call it, it's not a service, it's an agent. It's an agent. So this agent will report to API server. I told you right, this is the boss. So everyone reports to him or her. So kubelet is the agent which will be running uh, as a service in all your nodes. So this kubelet agent, it's a service. Yum install apt install kubelet, something will do that. So it will be running as a service, and it usually reports to API server. This has to be running. If let's say I stop the kubelet agent, this worker will be not ready. I mean, it's not. It will be a part of cluster, but it's not accessible because the agent is not running. The service is not running. So you have to make sure that the service is running always. Remember that. Okay. So that is one component. And there is one more component called container runtime. What is this container runtime? With Kubernetes, I told you we're deploying containers. But internally, who manages these containers? There should be some platform to manage these containers. Obviously, Docker and or container D, CRI, so many other, or Podman. There are so many things just like Docker. These are also softwares which are open source, which where you can able to use to build your own images and deploy containers. Got it? So either any of this has to be installed and running. Of course, we have Docker. We'll install container D also. Don't worry, maybe tomorrow, not today. I'll tell you why tomorrow. But yeah, container runtime should be present. Why container runtime? Is to manage the containers. I mean, to manage the container now which we have, whichever we created. It's like let's say I'm not getting an example, but see, just because you let's say bike is there or or let's a small thing, bike is there. You started the engine with the switch. I forgot that name. What is it? Self start. It's not the button, right, which is doing the thing. Whatever internally connected to it, that is doing. So it's like a on front face, that's the button, or let's say kick, the kicker we hit right. That is also same thing. We are starting the engine in a different format, but ultimately, who is doing the job? Whatever the engine, whatever inside it. Here also in Kubernetes, we are creating our parts to Kubernetes because it's giving us advantages. Ultimately, inside that, there has to be a runtime. As I told you, right? Without Docker, how can you run containers? I mean, without that's called container runtime or a platform to manage these things. Can you run Java application without Java? No, no, right? Similarly here, Kubernetes is a tool which manages the containers at the high level, scaling, deploying, and everything. If the container, once the container is created, it has to talk to the host, the kernel, or the host kernel. Everything will be done by container runtime. Let's say container runtime, Docker is your example for us. It stopped. You cannot create containers because the service is stopped. So you have to make sure whatever the container runtime you're using, it should be running always. Got it? And of course, the last component called kube proxy. It is one of the main things in Kubernetes. It manages the traffic within the cluster. I mean, obviously, you run a container, you want to access it with some port number, obviously, right? So how do we do access in this one Docker? By port mapping, the request will come to host network, from there to Docker network. Here also similar way, but there is a component for that called kube proxy, which manages the traffic routing for the services. I mean for the applications within the cluster. So it will assign the IP address to pods. If the traffic comes, this queue proxy will handle the traffic. Let's say we have 10 applications running. We have got a request from the class users that to access those things. It will only the one which transfers the request to the correct service. Let's say one request came. Okay, this is for service application one. It will transfer it. Application two request came. It will transfer to us. Like this. So this will set the establish the communication. Establish the communication in order to receive the traffic. And it will assign the IP address to for each and every container. Got it? So these are all called these three, let's say, worker components. In each and every worker, these three components will be present. It should be present. Kubelet, container runtime, kube proxy. So let's say four nodes are there. It means in each and every node, these three will be present. Obviously, you have to install the container runtime Docker. You will install this. This kube proxy will come by default. I'll show you tomorrow. Don't worry. We don't have to install this thing. And you don't install these things also separately. It's a package. When you install a cluster, these are all will come. What I did with the Docker Swarm, you need something command. It will initialize the cluster for you, Docker Swarm cluster. Similarly here also, unit command is there. Same thing. So you'll do that. I mean, you have of course you have to install the Kubernetes version, whatever required you want, and init the cluster, initialize the cluster. So it will give all these things, all these packages by default, all these services by default, components, sorry, as a package. And you don't need to install anything separately, except this, because this container runtime is not part of the Kubernetes. It's outside, right? So all you have to do is install this thing, container runtime, everywhere in master nodes and everywhere, wherever you are using it. So this is the overview of cluster. What are the components inside, how they talk to each other. One thing I want to say is, if you know, if you understand how it works, it'll be easy for you. It's dead easy for you. Even Docker, right? Once you understand the concept, commands are nothing. You can just simply use it because they won't change. Command won't change. They're static. All you have to know the concept, how it works. That's it. It's very easy. Similarly here also, Kubernetes also very easy. All you have to know is how it works. That's it. Where to look exactly. That's how you figure it out. So far it's clear. I mean, what is Kubernetes, what it does, how the Kubernetes looks like, and architecture looks like. Is it clear so far? Any doubts?
Not now.
Okay. So we'll do the installation tomorrow, not today. It's already 50 minutes up. But for until now, keep in mind that about this thing, how it works, this architecture. Keep try to remember this. And before closing, I want to say one last thing. See, how you access Docker? With Docker command, Docker space, whatever the commands we have. Similar way, how we access the cluster? I mean, how do we deploy everything? Of course, we're not doing it today, but how you're doing it? There is something called kubectl. Kubectl. This is the command line tool which will install along with the cluster, obviously. To this with this kubectl will access our cluster, Kubernetes cluster, and deploy our applications, create, delete, everything with this kubectl commands. Got it? With this kubectl commands. That's so with this kubectl we'll be doing everything. Got it?
Yeah.
So kubectl will just install along with the cluster, and don't worry about that. It's not extra thing. And one more thing before closing. So with Docker, we just have Docker Swarm. That's the only thing we use. But with Kubernetes, it's not like that. There are multiple flavors available. Multiple flavors. There is something called kubeadm, means Kubernetes administration. This is one of the flavor which is available. So there is one more thing called kops. There is one more thing called EKS. I forgot what. There is one more thing. What is it? Let me just see. What is the name of this? I forgot that. Let me get the name first, then I'll explain what are these. Minikube, yes, you're sorry. Now I got it. Minikube. Let me explain these things. What are these? Don't worry about that. It's just like the flavors are available. Simply just like Red Hat, Ubuntu, these are all Linux flavors, right? Similar in Kubernetes also, there are multiple flavors available. First is Minikube. So Minikube means we don't see this architecture. I mean, let's say you don't have multiple nodes, because usually Kubernetes have this cluster architecture, right? Master and multiple nodes. With Minikube, let's say you have only one server. You want to set up the master there, you want to run your application in that server only. At the time you use Minikube, which is called single node cluster. That's what accepts, right? Single node Kubernetes cluster. It means one server will be there. In that server, the master components will be running. These components also will be running, and you will deploy your applications within the cluster, within a single machine. I mean, it's called Minikube. If you want to have one server, you can install Minikube and you can use it. Kubernetes. Let's say you have this architecture, you have multiple servers where you want to one master and multiple nodes. At the time you can go for kubeadm, Kubernetes administration. The thing here is with kubeadm, you manage your own cluster. You have to install by yourself. You have to install all these things. You have to deploy by yourself. You have to manage it. I mean, troubleshooting, monitoring, everything. Got it? And this is called kops. KOPS, kops. Let's say you want to deploy your cluster in AWS. At the time, you can use kops. So what this kops does is it will integrate with AWS services, and it will give you advantages for AWS, which is called, you can use those AWS services on top of the Linux servers, and you can deploy it. But nowadays, no one uses kops. It's been a long time. EKS is called AWS service. AWS guys gave a service called EKS. So you can directly create a cluster in the AWS and you can use it. No need to install anything. You simply create it. Every cloud provides you a service. AWS EKS, GCP, GKE, Google Kubernetes Engine, Azure AKS. There's so many. Every cloud have their own Kubernetes services. Let's not go there for now. What we'll be doing is kubeadm, because we have master and we have nodes. So, and we install by ourselves. We manage by ourselves. So, kubeadm. Generally, people ask in interviews, what type of cluster are you using? Is it self-managed or managed, auto-managed or something like this? Self-managed means you install by yourself, you manage by yourself, you troubleshoot by yourself. There's only one thing for that, kubeadm. And if managed means managed by other guys, third party vendors called EKS. This we don't manage it. We just create it, they'll manage it. AWS guys maintenance manage it. This mini cube mostly they'll be used for just testing purpose in your local laptops or local machines. You have since you have one host, one machine, just install Minikube. That's it. It will give you cluster, Kubernetes cluster, and no use that. I never used it. That's why I forgot the name. Cops also not recently, maybe 5 years ago. I tried to use it. Nowadays, as I forgot completely how to install that also. So yeah, mostly we'll be concentrating on KubeADM for now because we'll be installing. We are installing a Linux machines. We don't know cloud as of now, right? We don't know AWS. I haven't told you yet. So as of now, I just have few Linux machines. I want to install Kubernetes and use it. So kubeadm is the one we'll be installing. These are all names of packages. I mean the flavors which are available in Kubernetes as well as the package names. So tomorrow we'll be installing kubeadm package. What is the package name for Docker? Simply just docker.io, I guess. Docker, if I remember correctly. Similarly, Kubernetes package name is kubeadm. Ultimately, Linux is the behind it. Linux is one behind it, right? Ubuntu, it can be CentOS, SUSE Linux, so many are there. But what is the flavor inside it? Linux only. Similar here also. Kubernetes is behind this. Just different package names. That's it. Depends on your environment. So what is our environment? I have one or two more nodes with one master something. So I'll go for kubeadm. Got it? That's what we'll be installing tomorrow. Any doubts here so far? Do watch a video or watch this one or any other YouTube also. Try to go with there is a official documentation for Kubernetes. So this one. So documentation. Okay. They'll give you. I am not sure who reads the documentation officially. Very less people here. But yeah, let's try it. There'll be everything available. So getting started. I think it will give you lab if you register. I'm not sure. Then practice it. That's okay. Tomorrow we'll do it. I'm sorry. See, Minikube, kubeadm. It will give you the whole thing. Minikube. See, all in one. That's all. That's okay. So yeah, any doubts in today class so far? Tomorrow we'll see the practical. Don't worry. Got it? We'll start with installation tomorrow. Installation may take half an hour. I don't. If we have any issues, it will take too much time. If not, just 5 minutes. That's it. Just 5 minutes. Not even 5 minutes. Yeah, let's an average 5 minutes. We can close it. Got it? So tomorrow's class timing, I'll say, I haven't got my schedule yet. Mostly it will be 8 to 9 same time, or 7 to 8 p.m. So is it okay 7 to 8 p.m. or 7:30 to 8:30? Let's forget about 7 to 8. 7:30 to 8:30 or 8 to 9. For me, 7:30 is convenient. For you, I'm asking you.
Fine for me, 7:30 to 8.
Yeah, 7 to 8 also.
That's fine. 7 to 8. I might get late for a meeting, but that's okay. 7:30 will start. 7:30 to 8:30. It's not confirmed
Yeah,
yet.
okay.
If I'm free tomorrow morning only, there will be class in our regular timings. I'll post you maximum by an hour. I'll post you. Okay, maybe within 10
Yeah,
minutes.
yeah.
Okay.
Yeah. So yeah, that's all for today. Let's meet tomorrow. All right. Bye. Bye everyone.